let's try to spot the pattern. To start, let's focus on the grey tiles. In stage 1, the grey tiles form a 2 by 2 square. In stage 2, the grey tiles form a 3 by 3 square. In stage 3, the grey tiles form a 4 by 4 square. So the pattern here is that the grey tiles form a square, and the length of the square increases by 1 in each stage. In stage 4, we'd have the grey tiles forming a 5 by 5 square. Now let's focus on the white tiles. In each of the first 3 stages, we have 2 white tiles. One of them juts out horizontally from the bottom right corner, and the other juts out vertically from the top right corner. Adding in white squares in these positions finishes off the pattern for stage 4. We have the first 4 patterns drawn out, so we can use this as a guide when we're counting up the number of tiles. Let's begin by focusing on the number of grey tiles. In stage 1, the grey tiles form a 2 by 2 square, which gives us 4 grey tiles. In stage 2, the grey tiles form a 3 by 3 square. This gives us 3 times 3 equals 9 grey tiles. In stage 3, we have a 4 by 4 square, which gives us 4 times 4 equals 16 grey tiles. For stage 4, we have a 5 by 5 square, and this gives us 5 times 5 is 25. Even though we don't have stage 5 drawn, we can continue the pattern. In stage 5, we'd have a 6 by 6 square, which gives us 6 times 6 is 36 grey tiles. Focusing on the number of white tiles, we can observe that each stage has exactly 2 white tiles, one jutting out from the bottom right and one jutting out from the top right. So we'll have 2 white tiles in each of our stages. To find the total number of tiles, we just need to add together the number of grey tiles to the number of white tiles. 9 plus 2 is 11, 16 plus 2 is 18, 25 plus 2 is 27, and 36 plus 2 is 38. In this question, we need to find a formula for Tn, the total tiles in stage n. To do this, we can generalize the pattern from the table we made out in part B. In other words, we can think about the number of grey tiles and number of white tiles in row n of our table. For stage 2, the number of grey tiles was 3 times 3. For stage 3, it was 4 times 4. For stage 4, it was 5 times 5. And for stage 5, it was 6 times 6. The pattern here is that the number we're multiplying by itself is 1 bigger than the stage. So for stage n, the number of grey tiles would be n plus 1 times n plus 1. The number of white tiles is a bit easier. It's 2 in every single stage, so there'll be 2 white tiles in stage n. The total number of tiles can be found by adding these 2 numbers together. So, we found an expression for the total tiles in stage n. It's n plus 1 times n plus 1 plus 2. We want our answer in the form n squared plus bn plus c, so here we should expand out our brackets. N times n is n squared, n times 1 is n, 1 times n is n, and 1 times 1 is 1. From here we can simplify a bit. N plus n is 2n, and 1 plus 2 is 3. Now, our expression matches the target of n squared plus bn plus c. b is the number in front of the n, so here b is equal to 2. C is the number by itself, and here c is equal to 3. In part C, we worked with an expression, Tn, which represented the total tiles in stage n. We want to have 443 total tiles, so we should set Tn equal to 443. In part C, we found an expression for Tn. It was equal to n plus 1 times n plus 1 plus 2. We can write this expression in the place of Tn and then solve the resulting equation for n. As a first step, we can rewrite the n plus 1 times n plus 1 as n plus 1 all squared. To remove the 2 from the left-hand side, I'll subtract 2 from both sides. We want to isolate n, so we'll need to get rid of the plus 1 and the square. Let's start by removing the square. The inverse of a square is a square root, so here I will square root both sides of my equation. The square root cancels the square, so we end up with n plus 1 equal to the root of 441. Doing some calculator work, this simplifies to n plus 1 is equal to 21. As our final step, we can get rid of the plus 1 by subtracting 1 from both sides. This brings us to a final answer of n equal to 20. So the 20th stage of our pattern will have 443 tiles.